Hello and welcome to today's video. Today we will be discussing how to count significant figures. So, how I learned how to count significant figures and how I think is easiest is with the arrow method. So the arrow method is super simple, super easy, super quick to learn. Let's get into it. So what you have to know with the arrow method is you have to know, is there a decimal point in the number that you are looking at and trying to figure out how many sig figs are in it? So for example, this number right here and this number right here, they do not have a decimal point, whereas the examples on the right, they do. And these are going to form two separate groups and ways to do it. So is there a decimal point? If the answer is no, you're going to think left. No equals left. And you can see this arrow is pointed to the left, and we're going to get into that. If the answer is yes, there is a decimal point, you're going to think yes is right. So an easy way to remember this is yes is right, no is wrong, no is left. So you really just have to remember yes is right and then no is left because it's the opposite of what's correct, it's wrong. So how does this help us? You are going to count starting at the first non-zero number going towards the direction we just talked about. So I'll show you how it works right here. So in the first example, this number does not have a decimal point. So we are going to move to the left. We're looking at in the direction of the left, and we'll start counting when we hit the first non-zero number. So we're going, boom, we hit it right there with the 4. So now everything after this is significant, and we're going to count it. So 1, 2, 3. 3 significant figures. Now let's do the next example. We're going to the left because there's no decimal point. Left is wrong. Left is no decimal. So we're going and we hit the 3 right away. So let's start counting because we hit it right away. 1, 2, 3, 4. 4 significant figures. So that answers the first two. Now what about a number with a decimal point? And remember, with is right. So you're going to the right. We're looking at it this way now. So we're moving our arrow to the right until we hit the first non-zero number. We hit it with the 1, and now we just count how many numbers are there. 1, 2, 3, 4, 5. 5 significant figures. Let's do the same thing with the next example. You're going to the right because right is yes, and there is, yes, a decimal point. So you're going and you hit the 4 right away. So then you just keep counting how many numbers are after that first non-zero number. 1, 2, 3. 3 significant figures. So you see how easy that was with the arrow method, right? Now let's know what all of the rules that encompass the arrow method are so you can feel sure and you understand the whole background of sig figs. So now we're going to break down the rules step by step that make up the arrow method and make sure you understand sig figs completely. So, rule number 1, non-zero digits are always significant. So what are non-zero digits? Any number that is not 0. So let's go and let's look. A 5 is not 0, a 3 is not 0, and an 8 is not 0. So all of these, 1, 2, 3, 3 sig figs, because all of those are not 0 and they are all significant. Let's do the next example. Not 0, not 0, not 0, not 0. So then you just count up how many of those are significant. 1, 2, 3, 4. 4 sig figs. Let's do the next one. I think you can see a trend. A 1 is not 0. A 3 is not 0. A 9 is not 0. And a 1 is not 0. So all of those, you just count up how many of those. 1, 2, 3, 4. 4 sig figs. Let's do the last example. A 3 is not 0. A 1 is not 0. A 4 is not 0. A 1, not 0. 5 is not 0. 9 is not 0. 2 is not 0. Let's count it up. 1, 2, 3, 4, 5, 6, 7. 7 sig figs. And you'll see in the corner here, I have the arrows from the arrow method in case you want to try these with the arrow method as well. It's just a little reference point, and you'll see the rules accumulating on that too as we add them. Think of it as a reference corner. Now, let's discuss the second rule. The second rule is any zeros that are between non-zeros are significant. So what does that mean? Let's look at it. So we know from the first rule right here, non-zero digits are significant. So we can go ahead and mark all of the non-zero digits. And now we're left with this 0. What do we do with it? Well, rule 2 says if there is a 0 between two non-zeros, then it becomes significant. So this 0 is sandwiched between the 3 and the 8, so that becomes significant. So here, 1, 2, 3, 4, 4 significant figures. Let's do the second example. Again, because of rule 1, we can mark all of the numbers that are not 0 right away because those are significant from rule 1. What about this 0? Well, we just learned that if it is sandwiched between two non-zero numbers, it becomes significant. So right there, that 0 is significant because the 1 and the 2 are hugging it. So let's count. 1, 2, 3, 4, 5. 5 significant figures. Let's do the next example. We know the 1, the 3, the 9, and the 1 are significant because of rule 1. They are not 0. What about that 0? It's tricky because now there's decimal places in and out. Do they matter? Nope, not in this situation. Not with the sandwich rule. So here, even though a decimal point is next to the 0, it's really still sandwiched between the 9 and the 1, so it still applies to rule 2. Because the 0, the two numbers next to it, that's all that matters. The two numbers that are surrounding it are not 0, so they make it significant. So here we're 1, 2, 3, 4, 5. 5 significant figures. Let's do the last example. We know the 3, the 1, the 4, the 1, the 5, the 9, and the 2 are significant because of rule 1. What about that 0? Again, because it's sandwiched between the 1 and the 5, they are non-zero digits. The 0 is significant. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figures. Great job. Let's move on to rule number 3. Rule 3 says that leading zeros, which we define as zeros that come before the first non-zero digit, are not significant. So let's do some examples. So this 0 right here, it comes before the first non-zero digit, which is any number, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, this one is the first non-zero digit, but the 0 is before that. So this 0 is not significant. But let's look at the rest of the numbers. We already know from rule 1 that 5, 3, and 8 are all significant. So that means 1, 2, 3, 3 sig figs. Let's do the next example. So now there's a whole lot of zeros. So we're going to go with all the zeros until we hit the first non-zero digit, which in this case is a 1. So none of these zeros are significant because of rule 3. So now what about the rest of the numbers? We know from rule 1 that the 1, the 3, the 9, and the 1 are significant. But what about that other 0? Well, leading back to rule 2, this 0 is sandwiched between the 1 and the 3, which makes it significant. So 1, 2, 3, 4, 5. 5 sig figs. Let's do the last example here. Again, let's look at how many leading zeros we have go until they hit the first non-zero digit. None of those are significant because they are leading zeros. None of those are significant. Now let's do the rest of the numbers. 1 is because of rule 1. 4 is because of rule 1. 1, 5, 9, and 2. All of those are significant because of rule 1. They are all non-zero. And I'm going to make this line a little more obvious so not to confuse you all. So the 1, 2, 3, 4, 5, 6. 6 significant figures. And that's rule 3. Okay, rule 4 says that trailing zeros, so zeros that are on the end, the caboose, they trail behind, in a number with a decimal point, so the number has to have a decimal point, are significant. So let's look into that. So right here, we go leading zeros like we discussed in Rule 3, they are not significant. So this one, we already know what we're classifying that one as. We know that the 5, the 3, and the 8 are significant because of Rule 1. But what about those last two zeros? Those zeros are on the end. They are trailing behind. And this number has a decimal point. So because of Rule 4, those zeros are significant. So let's count how many sig figs we have. 1, 2, 3, 4, 5. 5 sig figs. Now let's do the next example. So again, leading zeros before the first non-zero digit are not significant. So these 3 zeros are not significant because of Rule 3. Now let's look at the rest of the numbers. We know that because of Rule 1, the 1, the 3, the 9, and the 1 are significant because they are not 0. What about those last 2 zeros? Well, we know because of Rule 2 that that 0 is sandwiched between the 1 and the 3. So this one is significant. What about that last 0? It's trailing again, remember? It is on the end, and there's a decimal point in this number. So this 0 becomes significant. 1, 2, 3, 4, 5, 6. 6 sig figs. Now let's do the last example. So again, leading zeros before the first non-zero digit are not significant because of Rule 3. 1, 4, 1, and 5 are significant because of Rule 1. What about those zeros? That's a whole lot of zeros. Okay, so we know that this 0 is sandwiched between a 1 and a 4. That means it's a sandwich 0 because of Rule 2, it's significant. What about these zeros? That's tricky because it's a double 0. But those are still significant. And you could have so many more zeros in there. Let's say even 5. 1, 2, 3, 4, 5. Even if there was 5 more zeros in there, as long as the tail end of that sequence of zeros are 2 non-zero numbers, it's still the sandwich rule and it still applies. So don't look at it like, don't just look at this 0 and say, well, it's sandwiched because of this 0 and this 0, so that means it's not significant. That is wrong. You have to look at the overall picture, and these zeros are sandwiched by these non-zero numbers, so that makes it significant. So that's crucial to remember. Okay, what about this last 0? I'm going to erase all of this because that is not the number we are discussing. This last 0 is a trailing 0. It is on the end. And there's a decimal point, so that makes it significant. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 sig figs. Okay, we are on the last rule now. So the last rule says trailing zeros, like we just discussed, in a number without a decimal point this time are not significant. So now we're looking at numbers with no decimal point, and that means that those zeros are not significant. So let's do an example. So we know because of Rule 1 that 5, 3, and 8 are significant. These last two zeros, remember, they're on the caboose, they're on the end, and there's no decimal point in this number. So these apply to Rule 5, and there's no decimal point, so that means they are not significant. But the rest of those numbers are. So 1, 2, 3. 3 sig figs. Let's do the next example. The 1, the 2, the 6, and the 7 are significant because of Rule 1. But these zeros, we have to figure out what to do. This 0 is a sandwich 0, so that is significant. And the last 0 is a trailing 0 in a number with no decimal point. So that means it is not significant. This one is not significant. So now let's count. 1, 2, 3, 4, 5. 5 sig figs. Okay, last example. So we know that this is significant. The 3 is because of Rule 1. That 0, even though it's a short number, it is still a trailing 0. And there's no decimal point here, which means it is not significant. So here we only have one significant figure. Okay, Like I said before, the arrow method encompasses all of the rules because rules 1 through 5, that's a lot of rules to memorize. And I don't know about you, but there's enough things to memorize already. So let's just revisit the arrow method and I'll show you, now that we know all of the rules that define sig figs, I'll show you how the arrow method for sure works, just to prove it to you so you feel comfortable using it and you don't have to memorize all the rules. So these are the same numbers that we did before on that first slide. So you can see the arrows there and how many sig figs we said that there were. So just as a reminder, because there's no decimal, no is wrong, we're starting at the left until you hit the first non-zero number. 1, 2, 3, we said there was 3 sig figs. Now let's look at this number with the rules that we just did. So we know that 1, 2, and 4 are significant because they're not 0. And this 0 on the end is a trailing 0. And the number does not have decimal points, so it's not significant. So that one checks out. It is 3 sig figs from both the arrow method and the defined rules method. Okay, what about this next one? So we said that this number had 4 sig figs because you go to the left until you hit it. 1, 2, 3, 4, 4 sig figs. And you can pair it up to the rules, the color coordinating. Those are rule 1, this is rule 2, that adds up to 4. So this one also checks out. So both of our examples with no decimals checked out. The defined rules, it goes with the arrow method. Now let's check about the decimals. So remember, it does have a decimal. So yes, it does. So you're going to the right because yes is correct. Yes is right. So you go to the right until you hit the first non-zero number. 1, 2, 3, 4, 5, 5 sig figs. Now let's look at the defined rules. These zeros are leading. They are not significant. And then these numbers right here apply to rule 1. They are significant. This 0 is a sandwich 0. It is significant. And this is a trailing 0 with a decimal, so it's significant. And there you can check 1, 2, 3, 4, 5, 5 sig figs, checks out. And then the same thing with this last example. You go until you hit the first non-zero number, 1, 2, 3. That's the arrow method, 3 sig figs. And then all of these apply to rule 1. That's 3 numbers in rule 1, 3 sig figs. So here you can see you learn 2 different ways to do it. The arrow method, which fully encompasses all of the rules and is very simple. You just have to remember the arrows and then you just count starting at the first non-zero number. Or you can memorize all these rules. Either works, do whatever works for you. Now, here is a self-quiz. Please pause the video and take some time to write how many sig figs there are in all of these, and then unpause when you're ready to see the answers. These are the answers to the self-quiz. As you can see, I've color coordinated what the numbers apply to. So if you have any questions, you can go back and look at the color-coded rules and see what they apply to. The green ones mean it is significant, and red means it's not significant. So that you can figure out what all of those mean if you have any questions or got any of those wrong. Thank you so much for watching this video. I hope that you understand sig figs better. If you have any questions, please put them down below and remember to like and subscribe and write any comments below what you'd like to see next. Thank you.